क्या हम लोग?
Oh, yes, sir.
Okay, thank you. Okay, I think. So can you see my screen?
Yes, sir, it's visible.
Okay, thank you. So today, in the last class, we looked at few things in the polynomials, right? So today, using that theorem that we mentioned, I'm going to show you how we can factor. You know. Okay. So basically, I want to finding roots of a polynomial over a finite field with q number of elements. We will see how to do that. So I'm going to provide you a probabilistic polynomial time root finding algorithm. And actually, there are two versions of it depending upon whether q is even or q is odd. So this was discovered in 1980 by Rabin. So suppose, so there are certain simplifications. Fx is a polynomial in fux, and I have to find is roots of this polynomial fx, right? So what could happen? We may have, it may happen that fx is something like, L1x power u1, L2x power u2, then L sx power us times g1x power v1, g2x power v2, and GTX power VT. So it may happen. So what are these LIs? Li of x are linear factors. Okay, something like say x minus alpha or something like that, linear factors. And some powers are there are linear factors, right? So it could be x plus 1 whole square, x plus 1 whole cube, or x plus 2 whole cube, and something like that. And where are GIX, are typically are irreducible factors of degree greater than 1. Okay, both, we assume that actually not only both but rather fx as well, because so we assume that fx, I of x, and gj of x all are monic polynomials, means the leading coefficient is 1. Okay, so LIX are linear factors, so means degree is 1, and GIX are of degree greater than 1, irreducible factors, right? This is, suppose fx is like this. So each linear factor, so we know that each linear factor here, LIX, will give us a root, right? So suppose it is x plus 2, x plus 2 raised to the power 5. So we know that x equal to minus 2 will be a root of order 5, right? So these linear factors are nothing but root, whereas GIX are irreducible, means they have no root in FQ. This is something that we observe, right? Now, from the last class, we know that by the theorem that we know that the polynomial, this is a key polynomial, tricky polynomial that we are going to use it, x raised for q minus x, okay, is the product of all monic linear polynomials fqx. This we know from the result, right? This polynomial is known as master polynomial, right? So that means I can form, if I take the GCD, suppose I form a new polynomial f bar of x, which is GCD of x raised to the power q minus x, comma x. I take the greatest common divisor of two polynomials. So this will be nothing but L1x, L2x, LSX, right? So f bar of x has same roots as fx. Okay. So in other words, since fx and f bar of x has the same roots, I can assume that, our polynomial that I want to look at, I would say that without loss of generality, we assume that हम जिस polynomial का के roots निकालना चाह रहे हैं, we assume that fx itself is a product of linear factors, right? Is a product of linear factors, and we can also assume that it is square free, means no component is square there. So no factor of fx appears more than once. Okay, it's square free. Now, first I would like to describe. So that means our algorithm that we are going to work for. So we look for. I will try to give you an algorithm for finding roots of a polynomial in fqx, provided fx is a product of linear factors. So now, first, I am assuming that q is odd. Okay. So we are assuming that q is odd. So now, in that case, what we are going to do, I'll just give you the first description, then I will write down the algorithm. So know that x raised power q minus x can be written as, I can take x common. Since q is odd, I can always factor it like this. It's a very basic factor, right? So if q is odd, we can factor it like this. Okay. So for example, if q is 3, so it will be x cube minus x. X you take common, it is x square minus 1, which is x minus 1 into x plus 1, right? Something like that. Also, without loss of generality, we assume that, so already we have assumed that fx is a product of linear factors. Okay. We also assume that f of x has, or I would say that f of x does not have 0 as its root. We can also assume this fact. First thing that we assume that it is product of linear factors. Second thing, we assume that 0 is not the root of this polynomial, because if the 0 is a root, that means x will be a factor, right? We can divide it by we can divide by x if 0 is a root, right? Because then x equal to 0 will be a factor, we can divide it by x, right? So now fx is given, fx is our input polynomial for which we want to find the roots. So what is given? Fx is a product of linear factors and 0 is not the root of fx. This is given to us. Okay. Then we can write down using this relationship, actually keeping this thing in mind. What I can do here, we can write down fx as product of f1x and f2x, where what is f1 of x is GCD of x raised to power q minus 1 by 2 minus 1. Actually, this is comma fx, and f2x is GCD of x raised to power q minus 1 by 2 plus 1 comma fx. Okay. So if f1x is something like this, f2x is, so basically we are collecting the factors, right, out of this. So now the key crucial part comes for the algorithm. So we compute, so we can write fx as f1x, f1 of x, f2 of x, where f1x is this GCD, f2x is this GCD. Now we choose randomly, take any alpha in fq, okay, and then compute x plus alpha raised to the power q. What is x plus alpha raised to the power q? Since the characteristic of the field is q, this will be nothing but x raised to the power q plus alpha raised to the power q. बाकी जो बीच के एलिमेंट है वो सब जीरो हो जाएंगे because characteristic is q. Okay, when we expand, and now since alpha raised to q is equal to alpha, because right, it's a finite field with q number of elements, this is nothing but x raised to q plus alpha. Therefore, x plus alpha raised to power q minus x plus alpha turns out to be x raised to power q minus x, right? Right. We can just subtract. Now that means irrespective of the choice of alpha, no matter what is alpha, no matter what is alpha, irrespective of choice of alpha, the polynomial x plus alpha raised to power q minus x plus alpha okay, this polynomial is the product of all conic linear factors of fqx. So that means we can write, therefore we can write x plus alpha raised to power q minus x plus alpha, same thing as x plus alpha taking common, x plus alpha raised to power q minus 1 by 2 minus 1 x plus alpha q raised to q minus 1 by 2 plus 1, right? Again, just like in the previous case, without loss of generality, we can assume that x plus alpha does not divide fx. So again, we can write f of x, okay? F of x is equal to f1 of x, f2 of x, okay? Where f1 of x is GCD of x plus alpha raised to power q minus 1 by 2 minus 1 and fx. Just like in the previous case, f2x is nothing but GCD of x plus alpha raised to power q minus 1 by 2 plus 1 fx. Okay. So now, although the roots of x raised to power q minus x and x plus alpha raised to power q minus x plus alpha, right, are same, okay, the overall set is same roots are there, right? Roots of x plus alpha raised to power q minus 1 by 2 minus 1 are the roots of x raised to power q minus 1 by 2 minus 1 shifted by alpha. That's the only change. Therefore, we expect to obtain a non-trivial factor GCD of x plus alpha raised to power q minus 1 by 2 minus 1 comma fx of fx for some alpha. So this way we will produce non-trivial factor. Now this GCD is It was shown by Robin that this GCD is non-trivial. Sometimes it will be trivial as well. So non-trivial with probability at least 1 by 2 for a random alpha. Every time we have to choose alpha randomly. So this leads to our algorithm. Okay, so let me write it down the algorithm for you. Okay, so algo is finding roots of monic f of x in fqx. Remember, this algorithm works only if q is odd. We require some modifications because for q is equal to 2, the factorization of x raised to q minus x is not possible the way we have done. Okay, so then we need to adopt something else. Okay, so for this q odd, our assumption is remember our assumption was fx is product of distinct linear factors. Okay, because this was our assumption. If it is not, then we know that what to do actually, right? So we have already done those calculations. Now if degree of f is 0, algorithm returns the empty list. Zero तो trivial case है. If degree of f is 1, then what you do? Return the negative of the constant term of fx. Okay, because if degree of f is 1, so it will be something like say x plus alpha or something. So the constant term is alpha, then the negative of it is the root, right? Minus of alpha is going to be the root, right? Fine. Now we initialize the flag split found. I call it split found to 0. एक हमने फ्लैग लगाया, उसका नाम 0 रखा. While split found is 0, what we do? So this loop will run while split found is 0. Choose alpha from fq randomly. Anything I can take. So what will happen? We choose alpha randomly and we do the calculations. Sometime we get trivial factor, so we can ignore it, or sometimes we are failed to split. and sometime we will get a non-trivial factor. Okay, so for some alpha we will get our job. Our job is done. So compute g of x is equal to x plus alpha raised to power q minus 1 by 2 minus 1 mod fx. This is important. Everything is modulo fx. Then we compute f1 of x as gcd of fx comma gx. Okay, if degree of f1 is positive and less than f, what we do? Set split found to 1. Then we recursively call algo on f1 of x and also recursively call algo on f of x divided by f1 of x. Then we close it. Okay, so again I will just look at the algorithm. So what it does, if degree of f is 0 or 1, it's this standard thing that we need to do, either return the empty list or return the negative of the constant term. Initialize the flag split found to 0. While split found is 0, choose alpha randomly. Compute gx is equal to x plus alpha raised to power q minus 1 by 2 minus 1 modulo fx. Then we compute f1 of x, the first factor we try to compute, which is gcd of fx and gx. If degree of f1 is positive and less than degree of f, okay, that means one factor is found, right? So means factor is found, and recursively call then this algorithm on f1x again, and also recursively call this algorithm on fx divided by f1x, which is the cofactor of f1x, fx divided by f1 of x, maybe some f2 of x or something like that, right? And then we keep on running this loop until we find all the factors. So I think the best way we can understand this algorithm by an example. So let me give you one example, and that will be good enough for us. Okay. Question is find roots of the polynomial f of x is equal to x raised to power 15 plus x raised to power 12 plus 2 times x raised to power 6 plus 3 times x raised to power 4 plus 6x cube plus 3x plus 4 mod f73 modo 73. Okay, तो हमको इसके रूट्स फाइंड आउट करने हैं. That means we want to factor this into linear factors as well as that irreducible factors. That's what we need to do. So what we do here, let Tx is the polynomial x raised to power q minus x, which is 73 minus x. Right? Now we take x common and divide this polynomial by fx and look at the remainder. It turns out that this is nothing but 48 raised to 48 times x raised to 14 plus 4 times x raised to 13 plus 23 times x raised to 12 plus 14 times x raised to 11 plus 43 times x raised to 10 plus 6 times x raised to 9 plus 9 times x raised to 8 plus 72 times x raised to 7 plus 65 times x raised to 6, 67 times x raised to 5, 33 times x raised to 4 plus 39. It's quite heavy, big, but x cube plus 24 times x squared plus 30. I have divided by fx and looked at the remainder of the polynomial. So this turns out to be this. Now replace our x, because we don't want to do our actual x, replace fx by GCD of fx and tx. Okay, look at this GCD. It turns out that this is x raised to 6 plus 17 x raised to 5 plus 4 x raised to 4 plus 67 x cube plus 17 x squared plus 4x plus 66. So that means that fx has 6 linear factors, right? And 6 root in F73. And we need to find all these 6 roots and 6 linear factors of this polynomial x raised to 6 plus 17 x raised to 5 plus 4 x raised to 4 plus 67 x cube plus 17 x squared plus 4x plus 66. So a little larger, but it's not difficult. Okay. So what we do, remember, so we try to split this polynomial fx. So maybe I should write it down. Fx is equal to x raised to 6 plus 17 x raised to 5 plus 4 x raised to 4 plus 67 x cubed plus 17 x squared plus 4x plus 66. Okay. So now what is the task? Remember, pick some random alpha out of F73. Pick alpha is equal to 19 हमने ले लिया, ठीक है, in F73. Some random. Then we compute. Now, so what will happen? Either we will get a linear factor or we will not get a linear factor, right? So compute gx, which is x plus alpha raised to power p minus 1 by 2 minus 1. Same thing as x plus 19 raised to power 36 minus 1. And this is nothing but, again, we reduce it to modulo fx. It turns out to be 21 times x raised to power 5 plus 29 times x raised to power 4 plus 7x cube plus 46x squared plus 4x plus 30 modulo fx. Okay, we divide the whole thing by fx and the remainder is this. Now the next step in the algorithm, so first we choose alpha. If you remember, in the algorithm we choose randomly alpha. and we compute this. Now we need to compute the GCD, right? So I call a polynomial f1 of x, which could be a factor. We need to check what happens. GCD of gx and fx. What is this GCD? It turns out that you can compute the GCD is x square plus 44 of x plus 43. Okay. So that means one factor we got. So second factor f2 of x, which is the cofactor, will be fx divided by f1 of x. एक factor तो मिल गया है, उसे divide कर दिया, and that turns out to be x raised to power 4 plus 46x cube plus 54x square plus 20x plus 27. So that means we are able to find two factors, right? X square plus 44x. डिग्री 6 का पॉलिनोमियल था हमारा, अभी एक डिग्री 2 का पॉलिनोमियल मिल गया, एक डिग्री 4 का पॉलिनोमियल मिल गया. We are able to factor two of them. We have got two of them, right? We are successful in splitting fx into non-trivial factors, right? Now our job is to factors f1 of x and f2 of x. So अभी हमारा last part algorithm का आता है that we are going to again apply the algorithm of f1 of x. जो हमने डिग्री 6 पे किया वही हम f1x पे करेंगे और f2x पे करेंगे, ठीक है? So now try to split f1 of x, which is x square plus 44 of x plus 43. Again, what we need to do, choose some random alpha. So I take for alpha is equal to 47, alpha is equal to 47 हमने लिया, and then you compute g1 of x, right? g1 of x will be x plus 47 raised to power 36 minus 1. It turns out to be 0 modulo f1 of x. Okay, now rather than f of x we have f1 of x. Okay, so now we got g1 of x. Now we compute the GCD, the next stuff. GCD of g1 of x and f1 of x will be what? Because it's a multiple, right? It will be f1 of x. Is a trivial factor, right? So it's not very good. So this alpha is not working actually. It's trivial factor of f1 of x, right? So try different alpha. Now if you try alpha is equal to 57, then what you do? Compute g1 of x is equal to x plus 57 raised to power 36 minus 1 modulo f1 of x. This turns out to be 71 when we compute modulo f1 of x. Okay, then again we compute the GCD of g1 of x with f1 of x, and this GCD is 1, again a trivial factor, right? Trivial factor of. So try some other alpha. This time we try alpha is equal to 67. I am just showing you different alpha, what happens, Again compute g1 of x, which is x plus 67 raised to power 36 minus 1. This time this value turns out to be 66 plus 64 modulo f1 of x. Same polynomial अभी हमारा f1 of x चल रहा है of degree 2, right? So now we compute the GCD of g1 of x with f1 of x, and it turns out to be x plus 43. So this is a non-trivial factor. Of f1 of x. f1 of x of degree 2. Remember, f1 of x was x square plus 44x plus 43. So we have found one factor. And so root will be, this yields root. Root is minus 43. Mod 73. This will be what? 30. Yes. 30, right? Now, so we found one factor, which is x plus 43. So I divide the whole polynomial. So we can, what will be the cofactor here? Cofactor will be f1 of x divided by x plus 43. And this turns out to be x plus 1 is also a linear factor. We have found another factor. तो हमारा डिग्री 2 पॉलिनोमियल के हमने दो फैक्टर फाइंड आउट कर लिए, एक x plus 43, दूसरा x plus 1. So this will yield the root minus 1 congruent to 72 mod 73. So that means यहाँ पे हमने दो पॉलिनोमियल्स निकाले थे ना, एक ये f1x निकाला था एक फैक्टर, इसके दो फैक्टर हमने निकाल लिए. अब हमारे पास बचा है दूसरा ये डिग्री 4 का पॉलिनोमियल. f2x is x raised to power 4 plus 41x cube and so on. So let us consider the next one. So we try to split f2 of x, which is x raised to power 4 plus 46 x cube. Actually, it is 46, right? I think I have written it wrong. Yeah, this is 46. I forgot to write it. It's 46. Yes. 46x cube plus 54x square plus 20x plus 27. Now we try again some random alpha. Suppose alpha is 33. We compute g2 of x, which is x plus 33 raised to power 36 minus 1, turns out to be 3x cube plus 19x square plus 41x plus 64 mod f2x. f2x के mod हमें लगाना पड़ेगा. So now we can compute f3 of x. gcd compute करेंगे. gcd of g2x and f2 of x. And it turns out that the GCD is x cube plus 55x square plus 38x plus 70. तो एक फैक्टर आ गया हमारा जीसीडी में, तो दूसरा को फैक्टर हम निकाल सकते हैं. को फैक्टर विल बी f2 of x divided by f3 of x, turns out to be x plus 64 is a linear factor. It's a non-trivial factor, right? Say linear factor x plus 64. So root क्या आ गया? So root will be minus 64. I'm sorry. Minus 64 mod 73. This is nothing but 9. Okay. Now we are left with this polynomial x cube. f3x आ गया हमारे पास, right? This polynomial is there. We need to look at f3 of x. We try to split this x cube plus 55x square plus 38x plus 70. Again, we try different alpha. So suppose we try random alpha. Alpha is equal to 41. Then we compute x plus 41 raised to power 36 minus 1. It turns out to be 3x square plus 43x plus 4 mod f3 of x. Right? We compute GCD of g3 of x and f3 of x turns out to be x plus 6. So we got the root. So linear factor, non-trivial. Therefore, root is minus 6, which is same thing as 67, not 73. So we can now split the cofactor. f4 of x, cofactor will be f3 of x divided by x plus 6, and it turns out to be x raised to power square plus 49 of x plus 36. Again, we try to split it. For alpha is equal to random 8 ले लिया इस बार. So g4 of x is nothing but x plus 8 raised to power 36 minus 1 is equal to 31 of x plus 28 modulo f4 of x. Okay. Now again we try to compute the GCD of f4 of x and g4 of x. This GCD this time turns out to be 1. So we fail to split. Right? Try some other alpha. This time we can try alpha is equal to 25. So g4 of x is equal to x plus 25 raised to power 36 minus 1 is equal to 11x plus 13 modulo f4 of x. So GCD कितना होगा? GCD of g4 of x comma f4 of x. This time it turns out to be x plus 41. So root will be minus 41, which is same thing as 32, not 73. Right? So last root cofactor से आएगा. Last root will be f4 of x. The cofactor is f4 of x divided by x plus 41. And this turns out to be x plus 8. The root is minus 8, which is same thing as 65 modulo 73. So that means all the roots of fx, which is of degree 6, remember, are 9, 30, 32, 32, 65, 67, 72, mod 73. Mod 73. Therefore, our polynomial x raised to power 6 plus 17 x raised to power 5 plus 4 x raised to power 4 plus 67 x cube plus 17 x square plus 4x plus 66 will be x minus 9. सारे रूट में we write it down like this: x minus 30, x minus 32, x minus 65, x minus 67, and then we have x minus 72. That means I can just do modulo 73. This can be simplified to x plus 1, x plus 6, x plus 8. Everything is modulo 73. So negative sign we can get rid of. X plus 41, x plus 43, x plus 64. Modulo 733. So one can show that actual root, that in F73x, our polynomial x is for 15 plus x is for 12 plus 2 times x is for 6 plus 3 times x is for 4 plus 6 times x cubed plus 3x plus 4 is nothing but x plus 1 whole square. x plus 1 का एक फैक्टर रहेगा, ओके, x plus 6, x plus 8, x plus 41, x plus 43, x plus 64 times x raised for 8 plus 55 x raised for 7 plus 11 x raised for 6 plus 37 x raised for 5 plus 5 x raised for 4 plus 62 x raised x cubed plus 62 x squared plus 46 x plus 62 mod 73. So this is a irreducible factor of degree 8. Right, so this is how we do the factorization. So the first portion is a factor in the linear factors are multiplied by a irreducible factor. So the way we started, L1x, L2x, L3x, and so on, LSX, there could be some time powers because say x plus 1 is a double root, so x equal to minus 1 is a double root here, and all other roots are there, right? So I think that's all for today. In the next class, we are going to look at the characteristic 2 when q is equal to 2, okay? And then we will do few more factorization algorithms, which are popular ones for computing the factorization. Any question?
No, sir.
Okay, so I will be posting. Thanks, Komal. आपने अपना assignment भेजा मेरे को. That's good. I got it. And I think Komal and Ajit, right? प्रवीण, तुम्हारा क्या हुआ assignment का?
सर मैंने भी सबमिट किया है, आपने चेक नहीं किया लग रहा है.
किसमें सबमिट किया? एक्चुअली लोगों ने तो मेरे को मेल से भेजा है, शायद मैं भूल गया हूँ. गूगल क्लासरूम का लिंक मैंने क्रिएट किया है कि नहीं?
सर गूगल क्लास आपने वो डाला था ना, उसमें टर्न इन कर दिया मैंने सबमिट करके.
अच्छा ठीक है, मैंने देख.
मेल भी करना है तो मेल भी कर देता हूँ सर मैं.
नहीं ठीक है, मेरे को मेल मिली थी ना, तो मेरे को लगा एक ही मेल है तो एक ही ने किया है. ठीक है, आई विल लुक एट इट. ठीक है, आई थिंक इट्स गुड व्हाट यू हैव रिटन देयर. दैट इज नाइस. सो you need to do something else also. I will let you know, okay? So maybe we can put another assignment, okay, and then you can submit that. ठीक है, अब की बार इतना टाइम मत लगाना भाई. ठीक है, ओके, थैंक्स. सो आज का इतना हो गया. आज एक ही एल्गोरिथम करेंगे, नहीं तो फिर बहुत कुछ हो जाएगा. तो नेक्स्ट टाइम विल डू द अनदर एल्गोरिथम. ठीक है, फाइन, थैंक यू.
थैंक यू.